Okay. First of all, we will have 3 lesson today. Every one will be about 90 minutes to 105 minutes. I am planning to have a 15 minutes breaks for every lesson. Okay. All of them will be recorded. I am planning to record them. Please remind me to record them if I forgot, like before. Okay. Let me start with the final exam draft plan for the questions. I will have 2 questions about the database design. One will be from user interface, one will be from Excel or spreadsheet. Or you can think this question as an Excel-like table, and we are normalizing this table. One question will be about transaction concepts or transaction. And the other questions, according to the first 2 questions grades, I have not decided yet if they will be harder. They can be 15 point, 15 point, or 10 point, 10 point. I have not decided yet. After I create this one, this last questions will be about the SQL. Any questions about this topic? No question? Then let me start with our course notes. Okay, here we have this last one. You can see that this final exam questions will be here, but it seems that I made a mistakes. Let me fix it quickly. Okay, this will be like this. Okay, let's say small fix and push it again and come back here. Yeah, these are the final questions. Let me first start with a topic you will need in the exam. We have talked about it before, but I updated the course notes, and again, this is a normalization topic. You will need it since I expect the database design to be in the 3rd normalized form. The normalization aims to make insert, update, and deletes more understandable and clear. Okay. First of all, normalization is about how the data is stored, not how the data retrieved. For example, let's say I am normalizing a long table. Okay. Most of the time, when I normalize table, the tables will be divided. Could you close your microphone? Okay. In fact, normalization process normally divides given a table to 1 or more tables. Therefore, when we need to get this information from the normalized tables, we need to join these tables. Then this will slightly slow down our data access. Okay. Last time we have went over this article. Okay, a simple guide to find normals in the relational database theory. It is in our suggested readings here. Okay, you can download it like here and read it again. It is very short and very understandable read. It is old, but a good one. First of all, yeah, the basic ideas of the normalization are following. First of all, every table should have a primary key. We have talked about the primary key. They should have natural primary key or surrogate or synthetic primary key. Okay. Then every cell value in a given row and column in table should be identified by the primary key. Okay. When we are going over the normalization, this will be more clear. Every cell should contain only atomic values. Okay. And if you look at the Wikipedia, there are 11 different types of normalization. Okay. Let me open this one and show it. Here, as you can see, unnormalized, first normal, second normal, third normal, and as you can see, there are a lot of different normalization. For us and for the most of the use cases, about maybe 99% of time or 1 in 1,000, this other normalization may be necessary. For most of the topics, this 3 normalization is good enough. Therefore, I will be expecting this 3 normal form as a normalization. For the others, since this is an introductory course, you are not responsible, but you should know that apart from this third normal form, there are other normal forms exist. That's it. If you go back, let's start with the these 3 normals. These 3 normals prevent insert, update, and delete anomalies. And in fact, when your tables are third normal form, they are considered in a normalized form. Okay, this is when please normalize your database means that make your database in a third normal form, not these all normalizations. And let's start with one example, the first normal form. In the first normal form, all records must contain same number of fields. The first normal form forbids multi-valued attributes and groups. Every cell should contain only atomic values. Okay, let's see one example. We have this ID and skills. As you can see, these skills are divided by comma-separated values. Programming, web design, databases, and algorithms. Okay, this is not in first normal form. Second one is this. For example, I have ID, name Attila, ID, name Attila, and I have phone 1 and phone 2 in the, again, in this same table. And this is not, again, normalized, not in first normal. Why it is not in first normal form? First of all, this one is about having, for example, this value, this Attila is, let's say, have a phone number 1, Attila phone number 2, but this, okay, this is not a very good example. I need to fix this one, since if it is only about the phone and the values, we are repeating this one, and it is, I should have one more column maybe here. Right now, if we think Attila is a foreign key to another table, and this is a, let's say, a natural key only for the name, then we can think this as a normalized version. I need to fix this example and make it better. But if this Attila is not a primary key to another table, therefore this is not a foreign key, then this is not a normalized table. I need to fix this one, and I missed this one. Sorry about this. But the first normalization is about the atomic values. We should not have a repeat of in same cell this comma separated values like this, or in the groups like phone 1, phone 2, and the others. Any question?
No, I don't have any question yet.
Okay. The side note is the atomic values. There are disagreements about the definition of atomic cells. Consider the following table. Here I have ID, Attila Özgür, and address. Again ID2, Duru Özgür, and again second address. Is this table in a first normal form? Okay. This depends. Okay. This here, the question is about, does the address and name values are atomic in this table? It could be argued that name should be divided the first name and last name columns. This is a good argument, very good argument actually. And the address column should be divided so that at least city, Ankara, and MG here, and country information, Turkey and Germany, should be in the different columns. And this is a very good argument. But the question comes where to stop. In the same way, we can divide any string value could be taught as a list of characters. For example, this example could be think of A, X, A, M, P, L, I, for example, or a date value could be divided to year, month, and day values. Here, you need to think about your application queries. If your application needs to deal with the first and last name separately, for example, sort and filter according to the last name, then this name column should be divided. And this is almost always the case. Therefore, dividing the name is almost always done. And in the same way, if your application needs to filter order data according to the city and country, again, this is a very, very common requirement. Therefore, then these two information, city and country, should be in the different columns. And also, according to your requirement, for example, you are doing a electricity related, and for example, TH, and you are providing the electricity to the homes, and this home no, this 20 is also important knowledge to you, and you should therefore divide this information, since you may not want to know which, for example, customers in the same apartment. But if you are working for a normal, let's say, e-commerce application, apart from this city and country information, these other parts may not be important to you. Okay, and therefore this division about the atomic cells depends on your application requirements. But for this table, the division of Attila and Özgür, this name and name to the first and last name columns, and this address to the street and or address line 1, then city and the country could be good enough. For the date values, the specific date functions will be helpful, and we have seen some of the date functions, as you may remember. Okay, there's here mathematical function, SQL date, and time functions, and therefore most of the time we don't have to divide, for example, these date values to the year and month. And the first normal form is actually design guidelines, since relational database theory does not deal with the variable number of fields. Okay, this is about no repeating values, either in a same column or either in a same cell or row. And we need to divide them and think about, again, this name and address example about this division. Then we go to the second normal form. In the second normal form is only relevant when the key is the composite. Okay, that is when your key consists of at least 2 columns. This is about natural keys. Even if you add synthetic key to your table, if your natural keys are composite, this situation persists. What I mean that, for example, I have suggested to you, for example, let's give example. For example, keys identity no. This is a natural key, let's say. And I can add, for example, person ID or person key as a synthetic key to a table. Okay, adding this synthetic key doesn't change the fact that this Turkish identity no is a natural key in this table. Okay, this example, we have an example by Kent, this simple guide to 5 normal forms in relational database theory. I have changed this example a little bit, and I added this example data. First of all, we have an equipment, then we have a warehouse. Warehouse means depot in Turkish, okay, or repository. We have this quantity, how many of these items exist in this warehouse, and we have warehouse address. Here, our composite key is equipment and warehouse. Okay, since without these 2 of them together, we cannot say about the laptop, since laptop can be in the main warehouse or branch warehouse. Printer can be main warehouse. It is not in here, but it can be in the different warehouses too. Therefore, to be able to identify one item, we need to know which warehouse in it and also which item in it. Since in the warehouse, we can have laptop, printers, monitors, and the other things. Okay. Therefore, for this table, we have two natural keys, equipment and warehouse, and these two are composite keys. Okay. Any questions about this one?
No, I don't have any question yet.
Okay, then we have quantity. For example, in main warehouse, as a laptop, we have 50 laptop. In the branch warehouse, we have a laptop and 10 of them. And here we have address 123 Main Street, City A, 456 Side Street, City B. Here, this warehouse address, okay, is not fact about this whole key. This warehouse address is about the warehouse itself. But for our table, this 2 is the primary key, but this one is an extra information about the warehouse. It is not an information about two of them together or the item in that warehouse. Okay, this is not this warehouse address is not an information about this laptop in a main warehouse for this column. Okay, the problem of this design are as follows. The warehouse address repeated for every equipment. As you can see, for laptop and printer, I am repeating this warehouse address. Let's say I have 50 different equipment in this warehouse, then I will be repeating this warehouse address 50 times. If warehouse address change, every row in this table for this warehouse has to be changed. I cannot say that this I need to change everything in this warehouse, this table, to be able to change this address. Since data is redundant, address information may be updated wrongly. Update anomaly. For example, I can say when I am changing this warehouse address, I may change, for example, this one as a, let's put this one in an, let's say, calculator. Okay, this is my address. Let's say I have tried to update this one. I can update only one of them. Then this is main warehouse, this is main warehouse, but as you can see, these two addresses are different. It is a little bit harder to do with the SQL, but you can make such a mistakes in the spreadsheets, and also you can make such a mistakes in the cursor-based updates. This table, for example, could be updated with table-like structures. Then when you try to change this warehouse address, this could be changed only one place and the others may be forgotten, for example. And the last one is the one of the important part. If at a point of time there is no equipment in a given warehouse, we lose the address information of the warehouse. Okay, if we think this warehouse address is given only in this table, okay, and I finished everything in this main warehouse, let's say I sold these two of them, okay, where is the main warehouse address? Nothing. And this is a delete anomaly. Therefore, to change this to the second normal form, okay, this design should be changed to second normal form. First of all, the first normal form should be satisfied. Here, if we need to change this one, okay, this stays, TB, site state, this information, if we need to change this one to the, for example, warehouse T, and at the second column here, if we need this T information due to this atomicity. Okay. Otherwise, we will do this way. We will say that this is a laptop, main warehouse, quantity, and this warehouse addresses will be here. I think I need to change these warehouse addresses, and since they are not the same, this address and this address, I need to make them same. Let me take a note about this topic. Normalization session second normal fixed address second table. Okay, this is the second normal, and let's go to the third normal. In third normal form is about extra information in the columns. When a non-K column contains information about another non-K column, third normal form is violated. For example, we have employee, department, and building. Here, my key is, natural key is the employee. I have the department information, and it will show that which department my employee is in, and I have a building information. Here, this question is if each department is located in the single building. Okay, this is one requirement given. Then the building column is about the department, not about the employee. Okay, if I have a company and any department could be in a lot of different buildings, then this design is correct. There is no problem in this design. But if every department, each department is located in a single one building, then this design is problematic, since this building information is not about the employee, but it is about the department itself. A non-key information, non-key column building is the information about another non-key info column. Here is about department. Okay, then the problem is this one. The building column is repeated for every department. If building changed for a department, let's say company decided to move marketing to a new building, then every marketing employee row has to be changed. Since here marketing is in main building and I have, let's say, 10 marketing employees, then I need to change this information for all of them. Due to redundant information, data update and insert anomalies may occur. For the same department, different rows may show different building information. Okay, to be able to this one correct, again, I need to say each department is located in a single building. Okay, this is the requirement. If a department has no employees, for example, we have established a new department, an IT department, it is not here, and we have decided we need an IT department, information technology department, how to store building information of this department? Okay, in this design, we cannot do that, since in this design, every department should have at least one employee so that we can store this building information. How to fix this one? First of all, first and second normal form has to be satisfied. Then we divide this extra information to its own table. Okay, since this building is about department, this employee is about department, we have this employee and department in one table, department and building in the second table. Then finishes our normalization. As I have said, I will be repeating this normalization examples again. I suggest to you, okay, I will fix these small mistakes in my notes and then read this one again. You can find a lot of normalization videos online, normalization tutorials online, since it is a very well-known and very much required topic. You can also look at this other information. Okay, but normalization is about, okay, making this insert, updates, and deletes more clear and reducing this data entry errors. And to be able to have our database designs, we need to have them in third normal form. You can also read this one. This is again a simple guide, and it is a very readable one. And I think this is it about the normalization topic. Do you have any questions? Okay, no questions, then let me continue.
No, I don't have any question. We can continue.
Okay. As I said, database design for a given paragraph and also user interfaces and also spreadsheets is an important skill. Therefore, I will be asking you to design databases from in the exam, first from user interfaces and second from these spreadsheets. Okay. Let me go over database design from user interfaces. First of all, giving a database tables or the database design to the customer is not a correct thing to do. Most of the customers do not have necessary skills to understand database design. But the mock user interface, okay, or designing user interface in the requirement phase is almost always easier, okay. Using these user interfaces, since they are usual, your non-technical customers, non-technical user will give feedback more easy to you. This will lead to better database design. For example, let's say you have decided to put city information as a text box, but they will say that we do not want to have this information as a text box. It should be from a pre-selected or pre-entered list. Then you should change to the drop-down list. And when you change this one to the drop-down list, you need to change also your database design accordingly. Okay. Also, mock user interfaces will help visualize data flow of your applications. Okay. And this is about requirement phase, but also modernization of the old software is very much necessary in our industry. Okay. This example I have given in the last week. This Indiana bakery, it is still use Commodore 64s for its cash registers. If you think about it, Commodore 64, Commodore 64. Okay, last 30 years ago, the last Commodore 64 produced. It means that these guys are still using a computer. You could think this computer as a relic, but you can have a lot of this old software around from 10 years, 20 years, like here 30 years ago. Another example is a mainframe usage. For example, here we have a mainframing example. This is a display image summary. This is an invoice date, subtotal, discount, sales ask, freight, billing, and the other information. And this screen maybe, for example, should be changed to a modern web-based software. For such a things, we need to design our databases, new databases, according to this old screen. Most of the time when customer wants to modernize their software, they also ask you to modernize their screens, also adds a lot of new information. But since their old data stays, you need to design your databases so that you can migrate their old data. Also, you can handle this old functionality in your new screens, in your new system. Okay. Therefore, creating a database design from a user interface an important part. In the last week, we have seen this example. This was a retail screen. I think everybody remembers this one. And if you would like to this one, this is one of the solutions in the database design. In the second session, I have changed this design a little bit. I will merge these two of them, and you can look this question, and this is the answer. Okay. Let's see another example for our today's lessons in the database design. Any questions about this database design from user interface? Okay. let's start this one and put it to the desktop. Since I am working with the customer, in the computer, it will be a little bit more easy for me to work. And let's see, desktop, and open this one. Okay, this is our screen. Okay, here, how many tables we have? Could you give me some examples looking at this screen and table names? And I will be writing here this table names to do this screen. Yes, Aisha?
Customer table.
Okay, one is the customer, it is obvious. Then we can say product, since we have this one.
Would administer be okay?
Is it administer or is it something else? What is an
Employee?
administrator? Maybe employee, but think of it. This is a system, computer system. What do we have in the customer systems? A system administrator is a system. Here we have password. When do you enter your password? For what do you enter?
To log in?
Yeah, login. In the login, we should have something like user or login, as you say. Okay, system administrator by itself should not be a table, I think. Since we have system administrator here, we can have other types of users, most probably. Okay, then we have this, we have talked about this one. Let me click and select this part. Okay, we have talked about this, we have talked about this, we have talked about this. Others.
Maybe a table for the bills?
Okay, table for the billing. Billing is, let's say, definition table. Okay, I have said to you before, I would like to divide these tables as two types. One main tables, one definition tables. And here, billing is, or payment method. It is about billing, and it is actually a definition table. Okay, let's put this definition table here. Let me put this one. And let me put billing here. Anything else then?
Maybe
Here
subscription table for definition tables.
Here, most probably, this subscription is a table itself, not table. Since this screen is not a main screen, it is one of the screen in this system. We don't know the other tables or other screens. But here, since it says at subscription, then subscription is our main table. And in this subscription, we choose product, we choose which customer this subscription goes. Okay, the system administrator account is most probably about logging to this system. The billing is about the how this subscription will be paid. And here we have these acquisitions and the other parts, and this will be most probably will be decided. Okay, these may come acquisition and monthly. This information may come from other definition tables, or they may be calculated according to what we have entered here. For example, this additional products user, additional storage. This is about a subscription to a domain, I think, as an example. There we are giving this information, but other information here, this acquisition total what, acquisition total inch. I think this acquisition is calculated from this product. It is about domain name, alternative domain name, additional products, for example, 5 additional user and additional storage. And then we have this total information is calculated here, okay, from this information. Then this is monthly. For example, this is a yearly information, and it should be divided about monthly, total monthly discount what, and total monthly including what information in table. But you need to decide how we will store this information here. Let's say these are the main tables for now, okay? And let's start this information in our database design. Here, this does subscription shows that this is a domain subscription. Okay, let's say internet domain is a table name. Let me create SQLite, create an example, and let me say this is an internet domain example. Okay, SQLite test connection. Okay, finish. Here we have nothing right now. This is an old part. Let me, looking at this part, create these tables. First of all, let me create a subscription table. Table is subscription. I am adding a new key, subscription ID, subscription key, and it should be a okay. First, I need to create a new column, subscription key, integer, auto increment, and it should be primary key. Okay. Then when I am creating this subscription, I need to look at here. I have a license. This license, what is this license? How should I store this license information? Okay, starter, business, and enterprise. I think I should have this license as a definition table, and in it I should store this starter, business, and enterprise information.
Why is a license a definition table?
Why it is not? It is a, I am selecting this one from pre-selected list. Right now, as you can see, this guy is giving one project, 3 users and 60 megabyte. Who uses 60 megabyte right now? This is an old screen. This 60 megabyte most probably will change, but this starter business and enterprise classification will not change. Here right now, if I am doing a subscription in the same company, this one would be one project, 3 users, for example, 50 gigabytes. And here business 10 projects, 10 users, 1 terabyte. Enterprise unlimited projects, 100 users, for example, 200 terabytes. I don't know according to the how much money they will be willing to, but I don't think anybody will give 60 megabytes right now as a subscription. Will they?
No.
Then this information, this starter business and enterprise is something, this definition evolves in time. Okay?
Okay, I understand.
And right now, as you can see, I am selecting this one from a pre-selected list. Therefore, this is a definition table. Like this drop-down list example I have given to you. Okay? Otherwise, this could be a text box, something like that here. Primary domain name, alternative domain name. Okay? There is a difference between selecting from text box like here and selecting from this pre-selected list. Since this is a pre-selected list, this starter business enterprise, it should come from some definition tables. Therefore, I will be putting this license table here also. Maybe I should start with another table, create table, license, okay, license, create a new column, license, no, this is unique, auto number, primary key, okay, and create new column, license name, this will be text, not null, okay. I should add this information, one project, users, and storage. Project count, okay. Create new column, user count, and here storage size, okay. Here, as you can see, here when I make this license okay, a definition table, I was able to store this license name, license name, project count, user count, and storage size. This information, as you can see, this line, okay, one project, 3 users, 60 megabyte or 50 megabytes, 10 projects, 10 user, 1 gigabyte, unlimited user, 20 users, 3 gigabyte, okay. This information I was able to store here. Do you understand why I am putting this one in a definition table here this way?
Yes.
Okay. I can also, since I very much like naming conventions, okay, most of the time I put this license information and the others. My computer is slow. It was not able to, will be able to save it. Okay. Unfortunately, it seems that I need to close this one. Let me stop sharing a bit and kill this one and start it. Okay, I had to kill this DB Weaver. Let me open it again. As you can see, sometimes open source software is not so good. I am creating this license information. Since I like to have this naming convention, I am giving a definition table license. Okay, creating a new column, license key. This will be integer, unique, not null, unique, primary key. Again, I have a information here. It should be license name, license name. It will be text, not null again. Okay, create new column. We have a project count, integer, not null. We have user count, integer, not null. Okay, we have a storage size in, let's say, what was this one, megabytes. Let's say in storage size. Okay, again integer and not null. Okay, let me save this one. Let me copy it, execute. It is saved. Okay, since I have this storage size, I can go with the product right now, create table, and this will be product. Product is one of the main tables. In the product, again, I have a product key or product ID, as integer, not null, primary key. For every table, I should have one primary key. And since I have this license information, creating column, I need to have this license no. Okay, not null, since I need to have license every time. Okay, execute. Here I need to have a foreign key. Okay, this one license key, this one product, sorry, license key. My column will be the license no. Okay, let me cancel. This one should be renamed license no, since this is a definition table. Here I need to create a foreign key, license no. These are same. Okay, let me save. it is creating a table, product table, and executing this one. Then I go to the ER diagram. As you can see, I have a product, and I have also this license. Let me save it. Let's go to this part and let's continue. I have a primary domain, alternate domain, additional products, users, and additional storage. These are mostly easy from this table. Okay, let me go here, this part, DB viewer, here, primary domain name. This will be the text, since this is a text box. Okay, it is a not null. Okay, I should be have a, again, alternative domain name. This will be text. I am putting this one as a null. Why null? Since most probably this alternative domain name could be left alone. It could maybe it could be left empty. Therefore, I am putting this one as a null. But primary domain name should be, I think, filled. Otherwise, what he is buying. Create another column here, additional user count. Additional user count. This is, for example, can be not null, then default is 0, or could be null and default is not given. What is the difference? What you should prefer? Leaving as a null or making it not null and giving a default not null, default 0? No answer?
No, I don't know the question yet.
I can put this one is here, it is, okay, additional user count, and I can allow entering nulls to here, or I can make that this one is not null but making default 0. What is the difference? Allowing null or not allowing null, making it not null and giving a default value 0?
Maybe default value is better.
Yes, default value is better. Why better? Since here we are talking about additional users, okay? If default value is 0, then I do not have any users. But handling null is always harder, okay? When you are trying to design your databases, if possible, okay, try to make them not null. Here I have a chance to make this one not null and putting default 0. Here 0 users, 0 additional storage will not make any change to this domain rules, but it will make my coding, backend coding, and my database design more easier, since I will not need to handle these null functions. As you may remember, okay, we have these null handling functions, and we have talked about null a lot. Why handling null is not so easy, and actually it is a hassle. Therefore, when I am designing this one, additional user count, not null and default 0 is better. Again, create new column, add an additional storage. Okay, integer, not null, 0. This is again better. Then let me save, and this is my table. Here, as you can see, okay, with 2 tables. Product, I have finished everything here. This one project, 3 users, 60 megabyte is in this DT license, definition table license. Okay, the primary domain name, alternative domain name, additional products, this additional user Additional storage is here. As you can see, I am trying to replicate this label names to my column names. Why?
To make it easier to understand?
Yes, to make it more easier to understand for your customer. Okay, this labels, most probably we are thinking this screen as a mock screen. This screen we have designed with the customer, or this screen was given to us from their old software, for example. This is what they are used to. Therefore, this label names is what they are used to. Okay, if there is no reason to change, try to preserve their label names as your columns so that it will be understandable. Here, okay, I can easily say this license information goes to here. Okay, let me put it here. This license information goes to here. Project count, user count, storage size. Okay, this is my license information, and this is license no. Then primary domain name here, the alternative domain name here, additional product, additional user count here, additional storage here. Okay, then I can say that I did this everything here. This product part is finished with these two tables. Okay, this is what I am saying. Then let's go over these other parts. And for these other parts, we need to talk about this customer. Okay, we can select this one too. Okay, this is our table. And sorry, we will be designing this one. We have customer. Do I have any definition table in this customer table? These tables we have talked about. Okay, payment method and license. Payment method is about this billing, but we are talking about customer right now. Any definition tables here?
Would contact be different?
As you can see, what is contact here?
I can't read it that well.
Or let me put it here. This is our, this one. We have contact, first name, last name, email address, here company name, what number, address, and a country. Why these ones are white and this is gray? Any idea?
Maybe the contact information can be changed, but the company cannot be changed.
Then where will I get this company information?
I believe it's because of customer type.
Yes, customer type. When I am a personal, as you can see, contact, last name, email address will be filled. But if it is a business, contact, first name, last name, email address, plus company name, plus what number will be filled. This business or personal, which type I am changing will allow me to fill this part. Since this is a personal, the company and what number is meaningless. But if it is a business customer, then contact, then plus company name and what number I should enter. This screen shows me this how this table should work. Then we have entering this customer table. This is a normal table, and we are, let's say, customer key. Okay, this customer will have not null, unique type, primary key. We have this crate. Okay, customer type. This can be integer, and we can put type business personal, or you can write text and put this information here, business for business, personal or personal, or we can only store with character 1 as B or P as the first part. It should be not null. Okay, and let's say default value, for example, here personal, for example, for P. Create new column. We have this first name, but I am writing contact first name since this is contact. Okay, this will be text. As you can see, contact first name, contact last name, and email should always be given. I have create new column. This should be the last name. Okay, again, it should be text, not null. Okay, I should have customer, email, contact email, should be text. It should be not null again, since we will need this information. Create new column. Okay, company name should be text. It should allow null. Okay, again, create null. What number? Okay, this is number, but most probably it contains alphanumerical characters. It should be here. I am giving them as a null, since for business they should be entered, and here I should decide if the address, street, for example, since street address, city, postal zip code, and country are different information, I am putting them in the different address, city. Okay, again, this will be the text. Okay, create new address, postal code. This I can leave zip integer. Okay, and here create new column and address, country. Okay, since this is a drop down list, Netherlands and the other information. Okay, I need to save this one, but also I need to have one more column here, tables, create new tables. This will be the definition table, and it should be country. Okay, I need to add this country information, create new column, let's say country no, and auto increment unique. Okay, create new column, country name, this should be text. Okay, again, not null. Okay, save this one, save. Please. Okay. And here in the customer, I need to come foreign keys, new foreign key, and this foreign key should be for okay, save. And actually I need to change this. Execute. And here foreign keys. And if you go to again tables and look at ER diagram, we have this DT license, DT country, customer, and product information here. And if you look at our database design, let me close it, we don't need it. Close it, we don't need it. If you look at here, okay, customer information is, everything is here. We have this billing, this is payment, and we have this users information. Let us these tables create user here, users. Again, we have these columns, create column, let's say users key, integer, not null, unique, primary key here, okay. And here create new column, user name, this should be text, this should be not null. And if you look at this here, we have this display name and email address and password, therefore this should be here, okay. And display name, text, not null, okay. Create new column, email address, it can be email by itself, text, not null, okay. And we have password, and here again text, okay, and save. We have product, we have system administrator, account, we have customer, we need to have this billing. For billing, we have talked about, okay, it should be the payment method, that's the table. Let's come here, and here again, create another table. This payment method, create payment method, no, not null, unique, okay. If you look at this here, bank transfer and the payment method, and this should be the payment method name, it should be text, and it should be not null, okay. And we should save it. Here, since we have talked about we need a subscription table, since this whole thing is a subscription, okay. And I need to add a table here again, create new table, it should be subscription, new column, subscription key, and here auto increment and primary key, okay. And here what the subscription holds is product and customer and billing. Here product key, customer key. Since billing is no, sorry, payment method, let me cancel, save it here, execute. Since this payment method is okay, here again I have a problem, I am getting an error, therefore I'm closing this one, no, and coming here to this part and running it here. Sometimes this GUI part doesn't work very correctly. Therefore, like here, I need to close it, run the script, and come here. For this subscription, this is a definition table. Therefore, I am changing as a this one as a this data definition table subscription. Sorry, not this one. This payment method is definition table. Then I can go to this one, come here. This is columns. I can create a new column, payment method no as an integer. Okay. Then let me add foreign keys, create new foreign key, customer key. Okay, create new foreign key. Here payment method no. Okay, create new foreign key, product key. Okay, as you can see, if these key names are the same, okay, why doesn't like it? This one, it doesn't like it, therefore I am deleting it. Let me save and come back to here. Okay, execute. And here, create new foreign key. This is okay. Okay. I don't know why, but it works right now. Here, let's go to the tables and ER diagram. As you can see, everything is connected here apart from users, but this user information is here. It is used for the login. Most probably, we need to update this subscription table. Okay. And here we need to have a new column and say that created by user key, for example. And here in the foreign keys, we need to have a foreign key and user. And here this one created by user key. Okay. And save, execute, go to ER diagram again. And this is it. This is this part, but we need to have this acquisition and monthly part also in a one table. Most probably we need to have this acquisition and monthly in different tables and add them here, so that we can have this information about total information. This is most probably invoices. This is total invoice and this is monthly invoices. And I should have this information here, total monthly discount, VAT, and total monthly. And here acquisition total, VAT, and acquisition total as a information. And I can add them as tables also. But apart from these tables, this product is here, customer is here, billing is here, user information is here. And as you can see, everything is related to everything. It is in one way. Therefore, this is a relational database design from a user interface. And we have started subscription, customer, product, user, and login information. Payment method and license is also here. We have also added country as a definition table to our tables. Any question?
No, don't have any question.
Others?
No, sir.
Okay, then this is from the user interface. Of course, as you can see, even this relatively simple user interface has taken us a lot of time. Therefore, in the exam, I will ask more simpler version so that you can create it. Here, if I ask this one as a, let's say, here, third normalized form, do you think these tables are in the third normal form or not? How do we decide?
Can you ask again?
This table, this design, I have created this design using these screens. Okay, I have decided that apart from this part, okay, this, everything is here in this table. And I am asking that, given these database tables, are they in third normal form? Are they normalized?
I would have separated the address from customer.
Okay. For which rule?
I can't really remember, but I just remember it's not very good to have different information like this stacked up.
Here, if we look about this, let me look this part, okay? This normalization.
Could it be that since the customer information is not directly connected to the address,
Okay.
it should be
Let's go
separated?
over. Okay, let's go over. First normal. It should be a repeating one. Do we have something repeating? No. This country name dependent on country? No. This here, do we have repeating information? If this one address given for the one customer key, yes, we don't have any repeating information. We have this subscription key, customer key, payment method, credit, no repeating information. Here we have domain, primary domain, alternative domain name. If it was a names, for example, we should have added this to another table, but it seems that we have only two domains from this one, no problem. Here, username, display name, email, everything is dependent on this one. There is no repeating. Therefore, this is in the first normal. In the second normal form, we should have, okay, composite keys. Here, one key. Here, we have this customer key and customer type. It is a composite key. If you think about this customer, product is product key, license no, and the other information. Okay, license no, only one product, one. Here we need to think about if this customer key and customer type is a composite key. If we think them as a composite key, then this company name and what number could be put to do another table, and this could be given another key here. But this part is also quite acceptable design If we are purist, we can say that this customer type plus customer key is a composite key, and therefore we need to divide this company name and what number to the other part. This can be acceptable also, but this will make our let's say, how can I say, the backend programming is harder, therefore I do not want to do. Okay, this is a denormalized form here right now with the company name and VAT number. It is not fully conformant to the second normal, but I accept this one for this, since this two information is good enough for me. If I am using this company information in any other places in my system, then creating a new company table and putting this company key to here would be also acceptable. For the last one, okay, we have this information and it should be dependent on this other information. Here, as you can see, address, address city, address postal, address country. This is again first normal, this four of them. But here, do I need to divide them to do another table? Again, this is about requirement questions, okay? This is not, if you are thinking about fully purist version, this is not, again, as you say, not a fully normalized. We can put them to another table and put address key here. But to do that one from a backend programming perspective, okay, the database design never leaves alone. You need to think about your customer. You need to think about your developers. You need to think about your customers. Here, if I need to enter more than one's address for per customer, then I need to put this address information to another table. But if I don't need to, putting this one is here as a denormalized, a little bit denormalized form. And again, this is about the purist talking, is better, since writing this one in this customer table will be more easier. Here again, okay, this is about the requirements. Okay, this is not a fully normalized table if we think this customer type and customer key as a composite key. But if we do not think them as a composite key, a customer key is by itself is a key, then this is a normalized table. Again, a little bit it depends, okay? For the other normalized example, most of the time it is a clear-cut problem.
Okay.
Okay, then let me solve another simple design problem and finish first lesson, have a 15 minutes break, then continue. This is user interfaces. If you would like, there are some other examples here. You can look them, but here right now, I have given this subscription screen also. For the spreadsheets, we have talked about why we need to do this spreadsheets design, and let me put this okay, student advisor as a first example. Okay, we have this table. Let me write this one, calculator. Okay, this is our tables. We have student number, student name, student measure, department code, department phone, college name, advisor, advisor office, advisor building, advisor phone, student GPA, student class. First of all, why we are looking here? What is the primary key here?
Is it the student number?
Yes, student number is the here primary key, and the main table is the student, since we are putting this student information here. As you can see, student number, student name, student measure here. Also, we have this student GPA and student class formations. This is not in the first normal form. Why? Since we are repeating a lot of the information here. First of all, you can look at this type of Excel and say that, okay, what is the starting point? Here, student name, it seems student, but here department, okay, this should be another table. College, no, let me think if it is, which table in it should be. An advisor name, advisor. This should be, we can immediately decide, should be another table. Right now, I see 1, 2, 3 different tables from this one. Okay, I should divide this Excel to 3 different tables for a start. Let me come here again here, new connection, SQLite, create desktop. Let's say from Excel student, SQLite, let's say, okay, test connection, okay, finish. And here, let me create a student table first. We have student table, num, name, and measure. Let's create them. Not foreign key, I need to create columns. Student num, not null, and let's say unique, maybe auto increment. And we have this name, okay. And we have this measure. Let's say student measure. This will be the text. And let's save it for now. It's okay, but we have also this two information here, GPA and class. GPA, and it will be numeric. Okay. Why I put allowed null here? And I think I should make these ones not null. As you can see, I cannot make this one null. Let me create this and drop this one. Yes. SQL editor, new SQL script. At least for name, it should be text and not null. And let me run it. Refresh. Here's student table. Not null, student measure null. I need to also add this student class. Let's say columns, new columns, student class. Again, let's make it text for now, not null. Okay, save it. Okay, here this information for now, I put it here. Insert columns and insert columns, and here put this information. I need to have this department code, department name, and department phone, and I should have a college. Again, let me create another table. This should be department. Here I have a code as a primary key, department code, and text unique. Okay, create new column, department name, it should be text. Okay, and I have a phone, department phone. It could be integer, but let's say text, not null. Okay, and save. Here I have 1, 2, 3, 4, 5, 6, 7, 8. Why I divided this department code and I divided this student and department tables from a normalization perspective. I created these two tables. I have one department, one student table. You can easily say that these are two different entities, and that's it. One is student entity, one is department entity. To store them in a same table, okay, you need a good reason to do it. Otherwise, you need to store them in the other places, since you know that departments contain students, or student has a department. Okay. Here, that when I divide this information to student and department, I need to have one more information. This should be related. How will I do that?
Maybe a department ID?
Yes, I need to add a new column here, okay, and it should be department code. Okay, since my department code is text, I need this one should be text. Okay, then in the student part, I need to come to this properties and foreign key is new foreign key, and here, okay, I need to have this department code. Yeah, here these names are not same, therefore I have a problem. Okay. Save, execute. And here then I have information about students belongs to a department. Okay. These tables, when I am dividing them, they should be related. And here, if I create from these columns by itself, this one and this one, tables, but if I do not put this related foreign key here in the student, I will lose the information about which student is in which department. Okay. And here, this college, engineering, business admin, and sciences, then most probably we need to have another table here. Okay, tables, and this one should be college. Okay, I need to have a for example, in the columns I need to have a college, for example, no or key, not null, auto increment, primary key. Okay, I need to have a college name. This should be text. Okay, execute. Okay, for normal usage there is no problem, but otherwise I have here, this should be college no. Okay, not null. Okay, save it. I need to have a foreign key, college no, save it. Okay, and when I come to here, look the diagram. Okay, I have department, I have student, and I have college. Then I have created this whole information, and then I need to have this advisor. In another table. Advisor. Again, this is not a key, but advisor. In the advisor, I am putting a key, synthetic key, even though it is not here. Okay, not null, auto increment. Okay, I have this advisor name. This should be text, not null. Okay, then here I have office, building, and phone. For now, advisor, office, text, not null, advisor, building, text, not null. Okay, name, office, building, and lastly phone. Advisor, phone, text, not null. Okay, execute. Let's go to table. New SQL script, run it, come to here, refresh. This one, no, no. Here, the question is this one. This advisor for the department, advisor for the student. What do you think so? This advisor should be connected to the student or department. This is the data. Here, marketing department, advisor Attila. Marketing department, advisor Fatih. Then this advisor is property or feature of this student. We need to connect this advisor to the student. And it is mostly normal and it can be understandable by data. But let's say this marketing, for every marketing department, the advisor name was the same. You should go to the customer and ask that, does the every department has only one advisor. Then if they say, yes, in our departments, we assign only one advisor, then this advisor will be connected to the department, not student, okay? It is about user requirement, system requirements. Sometimes it may look obvious, but it may be different for the others. Therefore, we will go to this one, come here for the columns. Okay, we have this advisor, no, not null, maybe null. Sometimes students may not have an advisor. Create new code, and here we have this. Okay, advisor key. Then let me rename this one advisor key. As you can see, I am making this column names with the same. Then here, when I create a new foreign key for advisor key, it's automatically assigned, and I can save it. And let's come here. As you can see, everything is connected. Student, advisor, department, and college. Okay, and if you look at it, here our design, here this is the Excel. Here only one question comes, this advisor office, advisor building, okay? This building information, should we store it in another table or not, okay? Right now from the Excel, it doesn't seem necessary, but let's say we need to have this advisor building information. This advisor building is the information about this advisor. No, it is about the building information, and we are storing this information in this table. And if we need to store this advisor building information also, then we need to create another table here, like here, and put this building information. And again, we need to create a building no, okay. Then create a new column, building name, not null, okay. Save it, and here we have this, refresh, here building, it should be connected, and here I am coming to advisor, this building information should be building no, and it should be, or I should drop this one. Yes, create new column, say this one building no. Okay, in the foreign keys I need to create this one with the building. Okay, in the building, it seems that I did not make this one primary key, therefore I have a problem. This building, I need to come here. Let me delete it. Yes, let's say primary key from this one. Then when I come to advisor columns, create new column and building no. In foreign keys, create new. And this is it, I think. If I did not make any mistakes, I put student information. I have this department code information, department name, department phone, college name, advisor information here. Maybe I should put also this class information in another table, but it is not so much, let's say, necessary. Any question?
No, don't have any question.
Okay, then this is the database design. Let's have a 15 minutes breaks. I will start the next class in 2:10. Okay, please leave so that this.
So are we continue?
We have a break, 15 minutes. Then we have 2 more classes. You can see from this appointments.
Hocam benim dersim var diye ben giremeyeceğim, haberiniz olsun.
Yani sonuçta derste 70 kişiyiz. Diğerleri de aynı durumda.
Hocam, are you gonna solve questions about your final?